So 7.6, exponential functions. It is asking you to graph the exponential function below. So to do that, we would simply graph it on the calculator. So let's do that and see which one matches the graph here. What we need to do is go to y equals, we type in 2 to the exponent of x, and press enter and graph. So here's what our graph looks like. So let's go match it with the MathXL choices. So our answer is going to be B. That is number 1. Number 2 is asking you to determine whether the following table represents a linear or an exponential function, and it asks to explain why or why not. So what we need to do first is look at our x's and look at the values and see if they are increasing or decreasing by the same number. See if we add or subtract the same number each time. So to go from 0 to 1, we add 1. 1 to 2, we add 1. And from 2 to 3, we add 1. So they have a common difference of 1. Looking at the y's, going from 2 to 4, we add 2. Going from 4 to 6, we add 2. Going from 6 to 8, we add 2. So since they're both going up by a constant amount and they have a common difference, it will be linear. So we're going to say linear because all the x values have a common difference and all the y values have a common difference. So your answer is going to be A for this one. And that's number 2. Number 3, it asks you to determine whether the rule represents an exponential function and to explain why or why not. In order for a function to be exponential, you must have your variable, or x, being an exponent. So we have 2 to the x, so that makes it exponential. So looking at our choices, so since x is the exponent, it represents an exponential function, so your answer is going to be B, number 3. Number 4, it asks you to evaluate the function for the given value. So all you're doing is substituting in x for the number given. Our number we're given for x is 2. Take the x out with 2, you have 4 squared, which is 16. So my answer is going to be 16 for number 4. Number 5, you are also going to be evaluating. In this case, let's use the calculator since we have a decimal being raised to a power. Type in our expression, we have 20 times 1.5. X is 4, so to the exponent of 4. Press enter. We have 101.25. Let's see what it wants for our answer. It says type an integer or a decimal. So type in 101.25. And that's number 5. Now we're told a population of 60 foxes in a wildlife preserve doubles in size every 14 years. The function y equals 60 times 2 to the exponent of x is where x is a number of 14-year periods. And that models the population growth. How many foxes will there be after 28 years? So since x is a number of 14-year periods, looking at 28, there are 2 14s in 28. 14 times 2 is 28. So that means there are 2 14-year periods in 28 years, so our exponent is going to be a 2. So we're going to type in 60 times 2 squared. So let's do that. So we have 60 times 2 squared. That is 240. That means after 28 years, there will be 240 foxes. And that is number 6. Number 7, it is again asking you to graph the exponential function below. So let's graph it on our calculator. So we go to y equals, we type in 5 to the x power. Press graph. This is what our graph looks like, so let's match it with our choices. So looking at our choices, it matches D, so my answer is going to be D. Number 8, it is asking you to graph this exponential function, and then choose the graph that it matches. So let's graph this on our calculator. So click y equals, choose parenthesis, alpha y equals, and enter, 1 over 5, Close your parentheses. Make sure you go over outside the fraction first before you put in your parentheses. And then it'll be to the exponent of x. So the exponent of x. Press enter and graph. Here is our graph. So let's see which one it matches on MathXL. It matches D, so my answer is going to be D for number 8. Number 9, graphing again, so let's do that on our calculator. So we're going to press y equals and type in 2.75, then to the exponent of x. So this is going to be our graph, so let's match it on MathXL. So it matches with B, so my answer is going to be B for number 9. Number 10. A solid waste disposal plan proposes to reduce the amount of garbage each person throws out by 2% each year. This year, each person threw out an average of 1,300 pounds of garbage. The function y equals 1,300 times 0.98 to the x models the average amount of garbage each person will throw out each year after x years. It's asking you to graph the function. So we're going to graph this on our calculator and see which of these it matches. So let's do that. So go to y equals, I have 1,300 times 0.98 to the exponent of x. Press graph, and we see our graph is not on here. We're going to have to zoom out a lot to see it. So press zoom 3 and do that till we see our graph. Okay, now we're starting to see it, so zoom out again. Okay, so in the first quadrant we see it's going down. So let's see which of our graphs match that. Now I know our graphs look kind of funny here. So the one that looks closest to, because we're going down, it can't be A. B is going up. C is going up, is going to have to be D. And that is number 10. Now for number 11, it is asking you to find a solution or solutions of the equation. Now to find these, what we're going to need to do is write each side of my equal sign as two separate equations on my calculator and see where their intersected point is. So we'll write those as a system. I'll show you what I mean. So in y equals, I'm going to type in 4 to the x. Then for a second line, I'll do alpha y equals and enter 3 over 2, press over x plus 3. Now press graph. I'm going to fix my window, so zoom in 6 for standard. Okay, now we see our intersection points are going to be here and here, but we need to find exactly where that is. So this is what we're going to do. So I'm going to do second and see there's a chase button here. Above that is calc to calculate, so click that. Now I'm going to go down to intersect and press enter. Now I'm going to press enter for that being my first curve and enter for that being the second curve. So the first intersection of here, it says branch to the nearest hundredths, will be for the x 1.11, again hundredths place is right here, comma, y coordinate will be 4.67, you round up. So 4.67 would be the first intersection. So now let's go ahead and find the second intersection here. So just press graph, press second trace again, press 5, and now use your arrows to go closer to this intersection. So press enter here to choose the first curve being down there. The second one, press enter to make that the other one. Press enter for a third time. Now the intersection point down here is going to be these 2 points. So that's going to be negative 1.96 for the x, and it'll be 0.67 for the y, or sorry, 0.07 for the y. On MathXL, it says our solutions are going to be basically the x, because they're the numbers you'll put in for x to make the intersect to make those two equal to each other, basically. So let's type in just the x values. And it says separate my answers with a comma, so 1.11 for the first one, and negative 1.96 for the second one. And that's number 11.